Hello everyone, and welcome to a special guest webinar hosted by the Cloud Standards Customer Council. My name is Tracy, and I am Program Manager of the CSCC. Today we're joined by three speakers, Chip Childers, the VP of Technology at Cloud Foundry, Chris Ferris, who is CTO of Open Cloud at IBM, and Yui Cao, who's Cloud Foundry Runtime PMC Lead at Pivotal. And they're here to provide a technical overview of Cloud Foundry, including its core components, technical benefits, and future direction. If you'd like to download the presentation file, there's a link to the slide deck. It's in the chat box of the GoToWebinar toolbar. And following the webinar, we'll also post the presentation and a recording of the webcast to the CSCC website. You can find that on our events calendar. We'll have time for a Q&A at the end of the presentation, so if you'd like to pose a question, you can use the questions box in the GoToWebinar toolbar. And with that brief introduction, I'll turn it over to you, Chris. Thanks.
Thanks, Tracy. Welcome, everyone. Thanks for dialing in. We definitely appreciate it and your time. So back in June, I gave a webinar via the CSCC with Sam Ramji, who is the CEO of the Cloud Foundry Foundation. I'm one of the IBM board representatives, and we gave a high-level overview of Cloud Foundry, the foundation, what its goals and objectives are, and so forth. If you're interested and you weren't able to catch that particular webinar, it's actually also posted at the link that Tracy posted in the chat. But what we did was we got a lot of good feedback, but people wanted to go a little bit deeper from a technical perspective. And so this time I brought with me two, I think, of the best people to help provide that perspective of the sort of the deep technical understanding of how Cloud Foundry is put together, how it works, and also where we're going from a roadmap perspective with some of the future developments that we're currently working on collaboratively with, all the different members of the foundation. So I'm going to turn it over initially to Chip, and he's going to go through and provide the sort of the technical deeper dive on Cloud Foundry and what it's for and how it works and so forth. And then Yui is going to follow that up with an overview of what we're doing from a roadmap perspective, and then we can have some Q&A. So Chip, all over to you.
Fantastic. Thanks so much, Chris. I appreciate it. Before we actually talk about what Cloud Foundry is, and we will talk about its architecture, I wanted to try to find a way to transition from the discussion that Chris and Sam had in the previous webinar, where they talked a lot about the foundation's goals, but I think more importantly, they talked about Cloud Foundry as the notion of software that's really supporting a movement that's around the shift from traditional approaches to businesses operating themselves based on the notion of sustainable competitive advantage to what is really the new business world, the new business reality, which is where you have to embrace the concept of continuous innovation. Now, continuous innovation is an interesting problem for businesses, but when you think about how technology needs to evolve to support the need to continuously innovate within your organization, it leads us to some architectural patterns, it leads us to a set of requirements, and it also leads to an awful lot of work occurring in the industry around different platforms and technologies that can support that transition. I think most notably, one of the clear evolutions that's occurring in application architecture today is the shift from the monolithic and layered application, think either single jar file based apps or n-tier architectures that are very UI to app server to data tier centric, to one where we're thinking about the functions that exist within each application and breaking those apart into microservices, and then those discrete services are able to be recomposed in potentially multiple ways to let that business deploy different applications to maybe mobile devices, take the same basic logic, scale things independently so you could support maybe industrial internet connections into the services landscape. And so this evolution is very, very important to developers. But I think just as importantly, it's also causing some desire to think about what are the things that you need out of your underlying technology to support the microservices world. Things get a lot more complex when you're talking about many instances of many different applications. On the other hand, it actually simplifies quite a lot. There are two, I think, important drivers that are worth noting with microservices. And so one of them is that when you think about how you're going to reorganize your business around finding ways to support continuous innovation, you're going to quickly break up your organization into lots of small teams that are going to own various bits of function within the business process. Now, the microservices architecture is great because it allows those organizational changes to actually be reflected in the software itself. And there's even a law called Conway's Law that gives you an understanding of how organizational structures are going to impact architecture. So if you could jump to the next slide. Now, Martin Fowler, and if you're not familiar with him, I highly recommend you look him up. He does a lot of very thoughtful writing on various subjects around architecture and development practices. But one of the things that Martin's done is he's spent time thinking about, what happens when an organization takes a microservices approach to application development. What are the emergent requirements that you actually need to support here? He's summarized them as the need for rapid provisioning. Now, largely we think of this in terms of rapid provisioning of the basic infrastructure building blocks that are necessary for the software itself. Second, you have to have some level of basic monitoring. I broaden this one a bit. I really think of it as a basic level of operability. So what happens on day 2 after the applications are being deployed? You need to monitor them. You need to get strong telemetry. You need to be able to trace transactions through a more complex and distributed system. But you also need to be able to ensure that there's going to be automated health checks that are going to care and feed for the system once it's been deployed. So it's basic operability. The third was rapid application deployment. Now we'll spend a little bit more time on that in a minute, but that's really where Cloud Foundry shines. Cloud Foundry is focused on taking code and turning it into a running application and making that a very smooth process. And the last is DevOps culture, or you could broaden that and say the appropriate organizational structures and practices that allow for a seamless flow of application, both new and application changes, into production environments, and to really create strong feedback loops that allow for you to use the deployed environment as a way to actually sense and then feed back into the developers very, very quickly. So that's what Martin believes are kind of the emergent requirements. Next slide. Now there's another way to think about the applications themselves. So if you were to tear apart a microservice, you're likely to think about the service itself as having potentially 2 different components. At the top, you have the logic and the API surface area of that microservice. And underneath it, you'll have some level of data services. Potentially, it's just persistence, or it could only be communicating with other microservices. But for that top layer, what Heroku did back when they first rolled out was they spent some time codifying some of the best practices that they believed were appropriate for a microservices-driven approach to applications. And they've listed those as 12 different factors or 12 different basic premises that you need to think about as you're designing your application. Next slide. A good summary of the 12-factor model, though, is to really look at these 5 basic bullets. And each one of them is really important when you think about how you're designing your applications to run on a platform like Cloud Foundry, or even if you're going to use some sort of bespoke platform. You're still going to want to find ways to think about declarative formats for any of the automation that you're going to put in place. Now, when you're working with a platform, that declarative format is simply the ability to tell the platform what you want to exist and trust that it's going to occur for you. Second, you want to have a clean contract with the underlying operating system. That's really important because the idea that you're going to have application code that's tightly interwoven with specific features of an operating system and configurations of an operating system is dangerous, and that's where you get a lot of drift between various environments. The third is focusing on modern cloud platforms as the deployment target. That goes back to Martin's point about rapid provisioning. When you think about the infrastructure that you need, that's what the modern cloud platforms are providing for you. You want to be able to enable the application developers and app operators to really not have to be concerned with any of the physical infrastructure or data center concerns. They really need to be able to say, here's the code, here's the architecture of that application, here are the back-end services I need for it, and not be concerned with any of the provisioning requirements there. Fourth, minimizing divergence between dev and production. The Cloud Foundry perspective is that your dev environment, your staging environment, your QA environment, your production environment, they should all be the same, with perhaps the only difference being the scale that's being applied to each. When you have no divergence between those environments, one of the major issues with manual provisioning or the traditional approach to application deployment and the need for heavy change control procedures is really obviated. You solve for a lot of problems by being very clear that the dev through prod pipeline is consistent. And last, you have to be able to scale up without significant changes to the tooling, the architecture, and that really is very, very much intertwined with the idea that you want the application code to have a very clean way to think about the back-end data services that it's going to work with. You want to be able to separate the deployment of those data services from the deployment of the code. You would like to be able to scale that code horizontally, or both scale it up as well as scaling it down as needs demand. Next slide. And even that's not enough. There's actually quite a lot of additional things that you need to think through when you consider how you're going to run these microservices in an enterprise-based environment. That's where things like role-based access control to the various resources. Are you able to map an organization's, let's say, compliance controls effectively to the platform? Can you trust that on day 2, the application you deployed is still running? There's a lot of details behind each one of these, but they're really just trying to make the point that it's not enough to even just think about the application from the developer standpoint. Really, there's a day 2 operational story as well. Next slide. And now, containers are an amazing phenomenon right now in the industry. Now, the use of Linux kernel features and making it very easy to think about isolation and namespacing, resource isolation within a deployed server that you're going to be pushing code into, making that very user-friendly is very important. But they really aren't the whole answer. Now, Cloud Foundry does make use of containers within its architecture. We have, and we'll talk about this a bit in the roadmap discussion and perhaps through some of the questions, but containers really are an ingredient to our larger platform. And they're really not enough. You do have to have a system that's going to think about both the upfront process of getting from code to a running application and what happens on day 2. Next, please. We describe Cloud Foundry as being a cloud-native application platform, and that really is fundamentally what we're about. Go to the next slide. But there's a lot of platforms that are out there. We clearly have infrastructure as a service that went through a fairly significant hype cycle. It's incredibly important that infrastructure as a service exists. It's very, especially for when we think about those requirements, the rapid provisioning needs to be there. But the application developers' needs are a little bit different. The app dev is focused on the faster time to market. They need to be able to deal with iteration quickly. They'd like to leverage a lot of open source software. And then application operators really are the ones who then take that work of the developer, and they need to be able to continuously deliver the software out into production. Their needs are similar. If you think about what IT operations might want out of a infrastructure as a service platform and what application operations might want out of an app platform, the needs are similar when you talk about things like flexibility and agility, but the actual artifacts that are being moved are very distinct. Next slide. So I mentioned earlier that Cloud Foundry's primary goal for the app developer, the application owner, is being able to take the artifacts that are produced from the software development process and turn it into that running application. there's a lot of complexity built into that, but there doesn't need to be for the user. You should be able to say, here's the code, here are the dependencies that we have, this is the build system that we're using, whether that be Maven for a Java project, and then what is the architecture that I need when it's running in production? What is the backend data service that I need? Do I need a message broker? Do I need a relational database? How are users going to access the app once it's running? These are all very, very important things to understand, and it's what Cloud Foundry is aiming to make very simple for you. Next slide. So there's a question of unit of value that I brought up a little bit earlier. And with infrastructure as a service, that unit of value is the virtual machine, right? And very clearly, VMs are what most people think about when you talk about deploying on a cloud infrastructure platform. You're asking for a virtual machine, you're asking for a specific operating system. You're having to then think about how you're going to attach maybe configuration management to push code into that virtual machine or into a collection of virtual machines. There's a lot of coordination that really has to happen, and it only gets you so far. Now, for an application platform, that unit of value is the app itself. Details like containers are actually transparent. You're thinking about the life cycle of the app. You're focusing on describing the app architecture in a very declarative way. I even take this a little bit further and say that the true unit of value of a cloud-native application platform is the velocity with which an organization is able to push changes to its applications. Because that's how you actually get to that notion of continuous innovation, and you get the business value that you need. Next slide. I've been mentioning day 2 repeatedly. It's always important to step back and remember that the applications have a life cycle. Some of them live for years and years and years, but they do in fact have this life cycle where you need to start with the notion of building, make sure that it's easy to do. Cloud Foundry can do things like auto-detect the framework or the language that you're working on. It needs to be able to very easily then be pushed out in its first release. You then need to be able to scale it. You need to have integrated high availability and health monitoring. You need telemetry into the app. You need log aggregation and monitoring, policy and different auth rules to access it. And then there's the things like, once you're going to update that application, how do you do A/B versioning? How do you do rolling upgrades? There are patterns that are well established now for microservices deployments, things like a canary node deployment, where you'll roll out a new version of that application service in a very limited way to confirm that you actually haven't impacted the overall system. And then once you've kind of let that canary node sit there and you're sure that it's operating effectively, you're able to then continue the rollout, and the rest of the environment gets updated with the latest version. And all of that requires some thought, and CF aims to make that as simple as possible. Next slide. So this is I guess I call it the marketecture for Cloud Foundry. Let's take a look at this bottom up. Infrastructure. So the CF premise is that we support many different types of infrastructure. With IBM, obviously, you'll be running on the Bluemix platform. There's an infrastructure as a service component to that. That's how Cloud Foundry is able to be deployed for you. There are other options with the open source Cloud Foundry itself, going to other platforms like Amazon or really any OpenStack or VMware environment. And it's an extensible architecture that allows organizations to add cloud provider interfaces for different IaaS APIs. Now, going all the way back up to the top, think about the end users. And we're seeing, the majority of applications that typically get deployed into Cloud Foundry environments are going to be web-based, or they're going to be mobile backends. That tends to be the majority of use cases. But there's an increasing number of organizations that are using Cloud Foundry environments to support industrial internet applications. And those industrial internet applications are interesting because we're seeing a change from embedded systems working based on legacy protocols to ones where they're becoming a lot smarter. They're becoming part of the web effectively, which means they're communicating much the same way that browsers and mobile devices are communicating. And so you can get this consistency across your architecture, regardless of what that usage might be. Now, within Cloud Foundry, you can think of it really in three different layers. At the bottom, we have the concept of operations, right? Operations is critical. We know that you need things like logging. You need to be able to scale the platform. You need to just be able to deploy Cloud Foundry itself, which is a complex distributed system made up of multiple microservices. And so that should be as easy as possible. And it should also sustain itself and sustain the applications that have been deployed on it. Now, above that are the services. This is where the code that you write needs to rely on some type of service. And the Foundation has some what we call core services in it, the MySQL or the RIXCS implementation. There are others that are incubating right now. Each one of the providers and vendors that is offering a Cloud Foundry distribution or service is going to bring a lot of additional services to developers. The best example with Bluemix that I love to use is the integration with Watson. Machine learning is something that you can now all take advantage of, and it's very provider specific. And then you have the user provided service instances. This is a powerful function that will allow, especially if you're in an enterprise and you have some legacy environments that are already running, it's unlikely you're going to go take some legacy application and completely tear it apart. The best pattern there tends to be add API facades in front of the legacy applications and then expose those to the new apps that are being built within a Cloud Foundry environment. And user-provided services can help support that. And the last layer is the elastic runtime. This is where those 12-factor applications get deployed. Really, any type of application, web-based access to it. There's a lot of intelligence built into our platform around identifying, starting with the code, identifying how to build, pull in dependencies, package, containerize, and then run, as well as monitor those apps for you. Next slide. Now, coming up in later this year, the Cloud Foundry Foundation is going to be announcing the first of what we believe will be several certification programs that are really aimed at helping users of Cloud Foundry products and services. That first one will be what we call CF Core. And CF Core is fundamentally about saying that an online service that you might go use or a distribution of software that's based on Cloud Foundry that you'd like to go use, if it's certified, will be known to come from a specific release that the Foundation has made across all of our projects, a coordinated release, if you will. But we're also thinking about the user experience as you use more and more of this. You're going to rely on services. You're going to rely on plugins that might tie into the logging framework. And the Foundation's going to serve as both a home to many of these extension points, as well as we're going to work with the organizations that might not have an open source implementation of a service broker, and they don't want to house it within the Foundation, but they'd like to make sure that it's certified so that users can trust that it will plug into a Cloud Foundry cluster. And then last, the best part about open source is that you get an extended ecosystem, a lot of experimentation. This is the stuff that's out on GitHub that maybe an individual was scratching their own itch and they developed, or an organization has built something that's unique, but they chose to share it with the world. And that's the extended ecosystem. And the architecture allows for a lot of that extensibility, and will give us, the certification process should give us a way to help you as users understand the level of trust that you can have with a particular backend service or a particular plugin that would tie into the core of Cloud Foundry. Next slide. And I mentioned the architectural extensions. The way that we look at this, and this is certainly not necessarily comprehensive, but there are many extension points. I'll start with build packs. Build packs are the magic that takes the code itself and transitions that into a containerized application. We've got a command line interface, the CLI tool that supports a plugin architecture, and there's some fascinating plugin extensions that are out there right now that are codifying a lot of those best practices for application deployments. Things like the canary note, things like red-green deployments. And that plugin architecture is enabling that type of orchestration of the core Cloud Foundry units of operation. And there's quite a few more. There's again, the cloud provider interfaces. There's various services. Services could be deployed within a Cloud Foundry environment. Services that might live outside, but yet nearby, and services that could be online services that live outside of the enterprise or outside of the Cloud Foundry environment that you're within. Next slide. And with that, I can transition to Yui and have her walk through what's coming up next.
All right, thank you, Chip. So just going to go over some roadmap items. Next slide. So the big chunk of work that we've been working on is getting the rewrite of the backend out there, and we've called it Diego. This was originally the rewrite of the DAs in Go, but it has gone beyond that, and it's now a many-component backend. So the goals of this was to improve maintainability and extensibility of the runtime layer, and it also supports build packs and containers. So DAs before only supported build packs. And right now it's running in beta on PWS and some other service provider environments. Right now the team is focusing on making sure it scales well. It addresses a lot of security concerns, dropping down to unprivileged containers, for example, versioning, making sure all of the components that make up Diego can be changed without downtime. And we expect commercial vendors to start releasing productized versions of Diego in this next quarter. Next slide. So Greenhouse is our project for having Windows on or support for .NET on Diego. This is closely aligned with the Microsoft roadmap around containers. It's currently worked on by, it's a joint effort between Pivotal, HP, and CenturyLink on this project, and we're coordinating with Microsoft around the next release of Windows with Run-C support. Next slide. So these are a lot of different features from several different teams in the runtime layer that we're working on. Route services. So the idea here is you could insert a service into the flow between the router and your app. You could, for example, have an authorization service or an auditing service or some other type of metering service in between your app and the router. We're also working on support for TCP routing that's currently supported with Lattice, and we're working towards integrating that with the Cloud Controller and exposing that in the API so that you could have support for TCP routing to your application containers. We're also working, the routing team is also working on a routing API. So as opposed to broadcasting messages over NATs, and we'd like to move away from using NATs, we're developing a routing API layer that you can register HTTP and TCP routes over. We're also working on securely running Docker images. This includes username spaces, dropping Linux capabilities, and again, running unprivileged containers. The CAPI team is working on application process types, which enables running multiple app processes from the same code base. If you think of it like different start commands on the same code base, you might have a runner or a web process or a worker process and a cron job, all using the same code base. And part of that work we're working on, we ended up versioning the Cloud Controller API, and we're working on a V3 version of that, and that also enables we've decomposed the V2 app into smaller pieces. It's very interesting, and we'll be talking about that at CF Summit. Some of the capabilities that this enables. So we're also working on enabling asynchronous and temporary app processes so that you could, say, just run this thing once, and we'll ensure that it runs once at a time. So you could imagine running a job just once and sort of like cron. We're as part of the work on TCP routing and as part of what Diego is exposing, we'll be supporting multiple port containers per application. And apps can then have multiple routes on multiple ports. So you might imagine an admin route to your app and or a debugging route or something like that. Diego also supports SSH into your application containers. This will be, there'll be some security and governance. There's some policy we're developing around recycling those containers if someone should SSH in, and logging of that. Lattice, which we like to refer to as Cloud Foundry by subtraction, is now able to produce droplets. So you take your build pack and your app bits and you can run those on Lattice. UAA has support now for multi-tenancy with zones, so that you can, with the single UAA deployment, you could use it for multiple different apps and services, and those are all segregated. System components may now use Logaritr for metrics, so they can, instead of having a var-z endpoint that the collector job is polling, you can now have those system components inserting their metrics into Logaritr, and that'll come out of the fire hose. Next slide, please. So what else? We are looking into securing communication between all of the components and rotating of certificates. I believe how you can rotate certificates between the VM components. Runtime support for finer grained roles and permissions. So right now we have some pre-canned roles, and they're very specific and perhaps a little bit odd in what a role allows you to do. The space developer role, for example, allows you to do most anything. We realize that a lot of users out there would like to have separation of concerns around this and have certain actions limited to certain roles. We're also looking into supporting extensible tags or labels on the different resources and components. We're looking into the possibility of staging gates, so that you could run or hook into the staging process as apps are uploaded to the platform, and possibly run some license scanning tools or virus scanning tools there. The next item is isolation groups. We formerly referred to this as placement pools. The way we're looking at this now would be a tier of cloud controllers above many lattices. So the components that make up lattice, like a router, and Diego components would be all controlled by one cloud controller tier. And app containers may use custom CAs. So the idea here is that instead of having to fork build packs to include your custom CAs, you could configure the system to insert the CAs and be trusted on the root FS. And the path to this may also resolve some of our how you can similarly modify the etcresolve.com. All right, next slide. So longer term support for persistence. So there's some initial investigations into how you can have storage on Diego. And then we're also looking into container-to-container networking. So next slide. Yep. the Bosch roadmap. So some of these things are actually just completed. So Bosch recently finished support for compiled releases. This allows you to ship releases that contain the jobs and compiled packages for a specific stem cell version, like Ubuntu or CentOS, and that reduces the time for that job to deploy. There's UA support in the Bosch director, so if you wish, you can have your Bosch users connected to some separate identity provider, like Active Directory. There's work on the pre-start release job scripts, and we hope this will allow for support of migrations with Bosch. And they're a fair way through working on support for dynamic provisioning. So this is simplifying manifest and making it easier to easily dynamically provision deployments. There's some links there for job linking and first-class AZs. Next slide. So the services roadmap. The notifications team has been working on their V2 API to support batch sending, test sends, and a few other features that I believe that's nearly complete. We are also working on user-managed service brokers. So the idea here is that you could create a service broker at the space level or org level, and it would just be focused on the space, and it wouldn't require admin privileges in order to develop that private broker. To develop that service broker right now, there's a burden on service brokers to deploy their own environment, almost to work out the kinks there. There's some plan for support for SSO for service dashboards per instance, so that you could have the single sign-on experience for individual service dashboards per service instance. Your service provider may want to have configuration per instance protected by single sign-on. The notifications team is also working on a CLI tool to make that easier to operate. There's the concept of an echo broker. This is really a replacement of user-provided services. Currently, user-provided services, you can only create them per space, and you can't share that across. So echo brokers would be a full implementation of user-provided services exposed in the marketplace, so that you could define once some user-provided service. People could then see that in the marketplace, create service instances from there in whatever orgs or spaces have visibility to that service in the marketplace. And something else we were looking into is parameter prompts. So brokers could have a way to tell CF clients they would like to have these fields prompted for. Next slide. Chip, was this the slide something you wanted me to go over, or you wanted to go?
I'm happy to take this one. In addition to a lot of the features that Yui was talking about, there's actually a lot of work and thought that's going into taking a look at the entirety of all of the components that make up Cloud Foundry and applying a security discipline that elevates beyond the current security posture of the system. In fact, there's some work occurring right now out in frankly the open source world where the U.S. federal government's GSA is taking a look at how they can help provide guidance for how to deploy Cloud Foundry into regulated environments. We have the financial services industry starting to collaborate collectively on reference implementations and requirements that they have to continue to enhance the security posture and the compliance posture of Cloud Foundry as a platform. So next slide. And with that, I think we're done. So thank you, Yui. I think we have some questions.
Yeah, this is Tracy again. Thank you so much. I was just taking a look at some questions that had come in. Let's see. Here's the first one. You state about reusable components as a service. So how is this different from microservices, which again I presume is a service which is not tightly coupled? This is from the beginning of the presentation. You're talking about microservices.
Right. This is one that actually comes up a lot. I certainly get it a lot. With Cloud Foundry, we can integrate a number of services like database as a service, queuing as a service, Watson was something Chip mentioned earlier as a service, analytics as a service, and so forth, Hadoop clusters as a service. Pretty much anything can be bundled up as a service. Now, this is a little bit different than when we talk about something like microservices, which is really an architectural style for how you develop an application or a service. So a service that's integrated, like let's take database as a service, is probably implemented using something like MySQL or DB2 or Oracle or what have you as the back end. And that's not a microservice architecture thing. It's it's your typical what you normally expect with one of those database engines. It's a single thing. It can be clustered and so forth. But the details of how it's been deployed, how it's clustered, and so forth are really completely invisible to the end user. The end user is just going to request an instance of that service, of that database. Give me a database, give me a queue, whatever the sort of the instance metric is. And then you just deal with it. You bind it to your application, and you can just interact with it using its set of APIs. You don't have to worry about deploying it and upgrading it and all that other kind of stuff. That's provided for you. Microservices architecture is really talking about this notion that you compose the application from a number of independent, service-oriented endpoints, if you will, right? That typically provide a single function or a very limited set of function, and they're deployed independently. They have their own application lifecycle that Chip talked about in his presentation, but they're all integrated together to deliver an overall solution that can be scaled independently and that can be upgraded independently based on all the different moving parts. Does that make sense?
I think it did to me.
Cool.
Yes, thank you. Let's see, moving on. A lot of customers I work with think that Warden containers will slowly be phased out with Docker taking its place in the Cloud Foundry. Could you comment on that?
Yeah, I'd be happy to comment on that. So that is true, but there's two ways I'd like to answer the question. The first one would be to say that go back to the premise of what Cloud Foundry is attempting to do for you, or does for you. The platform is able to take the code and then deal with the aspects of running it within the cluster. The process of containerization is in fact an implementation detail of how you go from code to running clusters. And so the Warden container technology that's within Cloud Foundry today is in fact a key ingredient to our architecture. Now, I also mentioned earlier that there's a lot of industry activity around containers themselves. And I think most importantly what occurred very recently was that Docker Incorporated agreed, along with a number of other companies, IBM included, to take what's at the heart of the Docker approach to containers, the format as well as the runtime implementation, or what was libcontainer, and create the Open Container Initiative. So that Open Container Initiative is now the home of a broad industry effort around a common standard for containers, for Linux containers initially, but also their implementations on other platforms. Now, what the Cloud Foundry project is doing within the Diego rewrite of the Elastic Runtime is that we do have an implementation that is very similar to Warden. But recently, the project team that's been working on that said, fantastic, now we see that OCI exists. So what we can do is we can take some of the goodness that was developed in Warden that solves for specific use cases that Docker is not actually looking to solve. And we're able to then collaborate with the rest of the industry and bring those into the reference implementation called RunC. And Cloud Foundry will be adopting RunC.
Okay, thanks.
And just to follow up with that, Chip, that was a great point. But I think, again, what this allows is for, and you mentioned that there are other, not just Linux containers, but other platforms as well. One of the most important platforms, I think, is probably the Windows platform, and Microsoft is working on their own containerization, and they too have embraced RunC. So the beauty of it is that by Cloud Foundry embracing RunC for Diego as we go forward, we're able to run containers that are developed through the build pack process, containers that are derived from Docker images and or Docker files, as well as container images for Microsoft using the same Docker APIs and so forth. So ultimately, it's a natural point where everybody, as Chip said, is organized around this common standard for image formats and for how you interact with the runtime of a container.
Okay, next question. Could you talk a bit more about how microservices are connected to each other to build the overall app and how that's done?
I'd be happy to take it unless Chris or you would like to. All right. So that is actually a really good question. And when you start dealing with a lot of different and distinct systems that are out there, you do have the question of how do you do service discovery, right? So how does one service or the front end of your web application, how does it figure out where the other services that it's going to rely on actually lives? Now, there's a couple of patterns that you can employ for this. Some people approach it by putting something in place that will act as kind of the source of truth. There's an example as HashiCorp's console software can do this type of thing for you. So that's one approach. Now, there are other frameworks that exist out there that, for example, some of the Netflix open source software does service discovery as well. And so there are implementations of that run within some Cloud Foundry environments. And then I think there's also quite frankly, a relatively straightforward way to approach this if you consider Cloud Foundry itself and its routing functionality as being a very straightforward way to enable that service discovery. And so when you write your software, you're going to be aware that you have multiple other services that you rely on. And if you code your application in such a way that it refers to those dependencies via names, and those names would end up being routes within the CF cluster, it's fairly straightforward then for the CF cluster to then forward that request to the appropriate target. I don't know if Chris or you would like to add any more color.
I think that's a good answer. And again, you can, what you deploy into Cloud Foundry can be just about anything. and so in that case, you could actually deploy something that would be a sort of a central registry that provides the ability for your individual microservices to register each other with this, service discovery node, and then find each other through that, through that service discovery. So you can roll your own. And then I think the other one that I think that can be used obviously is DNS. And again, a lot of these are really a function of how have you deployed it. If this is something you're deploying on premises, then you actually have a lot more control over things than if it's a public cloud thing like a Bluemix.
Thank you. Do you have any data pertaining to the efficiency and savings from using Cloud Foundry over traditional deployment? For example, dollars saved in function point reduction or time to market, schedule duration, compression?
So the Cloud Foundry Foundation does not actually have data like that we've published to date. It is quite possible, and I'll see if Chris maybe has an answer, that the downstream organizations that take the open source Cloud Foundry software and then commercialize it, it's very likely that there are some TCO calculations that are out there that are specific to that distribution or that service.
Yeah, I don't have any specific data points on that other than, there's a few Cloud Foundry-based implementations out there, and just about every developer that engages them and tries it out is ecstatic over how simple it is to get going and how easy it is to, sort of iterate through the development. So, just sort of that, anecdotal evidence is really, in many cases, the thing that really sells it, not specific data points.
Right. I mean, from the summit, you had, Diego from A2F. They were talking about how the developers, once they were introduced to Cloud Foundry, would say, if you take it away from them, they'll hurt you. I believe, I think it was Humana that said they developed an Apple Watch app shortly after it was developed, and it took them 6 weeks, and they could never have imagined doing that without Cloud Foundry.
That's exactly right. And one of the ways that we, engage with customers is through hackathons, and it's really quite effective. Sort of, bringing home the point that Yui made about what, the folks at in the was it 18F in the federal government said to the senior management, don't take this away from us or we'll hurt you. That's really pretty much what happens when developers are exposed to a Cloud Foundry-based environment. They just they love the way that they can be productive almost instantaneously.
Great.
I like to phrase it as there's a significant reduction in the amount of yaks that are shaved in producing an application.
Yeah.
Developers just get on with the business of writing the software that's going to move their companies forward or just interest them.
Mm-hmm. Okay, I think we can get in another question that came in, asking about how Bluemix and Cloud Foundry are related. If you could just explain that briefly.
Oops, I was on mute. Sorry. I'll take that. So Bluemix started life as an implementation of Cloud Foundry. It's the same bits that you get from the CF release, repository on GitHub. This was about at the time that we actually announced that we were joining forces with Pivotal on the development of Cloud Foundry, and we were going to be working towards establishing the Cloud Foundry Foundation. And since that point, it has grown. We've added additional capability around and as part of the Bluemix platform. So we've taken advantage of the fact that we have OpenStack running out on SoftLayer, and so we've added provisioning of VMs to the user experience that you get with Bluemix. It doesn't change the nature of what Cloud Foundry is under the covers. The Cloud Foundry aspect of Bluemix is the same. It's obviously, we've evolved it over time along with the foundation and the collaboration we have around the code base. And we've also added a container service in our OpenStack environment that allows you to spin up Docker containers and interact with Docker containers sort of in their native with their native Docker APIs. And we did this because we recognize that customers have an interest in sort of the full spectrum of virtualization capabilities, and they want to be able to integrate them across the different platforms. But as far as Bluemix and Cloud Foundry are concerned, I mean, again, we're continuing full steam ahead with Pivotal and HP and SAP and Intel and the others on the development of Cloud Foundry, and Cloud Foundry will remain a significant portion of what Bluemix is as we go forward.
And to wrap up, how can a company or a developer get engaged with the Cloud Foundry?
That's a great question. So I think the starting point is go to cloudfoundry.org. That's our foundation's website. From there, it will depend on the level of interest. Are you interested in using Cloud Foundry? Well, there are links to the documentation for how to get started if you'd like to deploy it yourself. There's a process there. We highly recommend you take advantage of some of the free trials that are available from the various as-a-service offerings that are out there. Bluemix is an example. Pivotal Web Services is another example. That's a great way to get a taste for the developer experience itself. If you're interested in contributing, there's lots of ways to do that. And so step one there would be to take a look at the mailing lists as an individual, start to participate in the user discussions that are occurring. I would also recommend that people strongly consider coming to one of the upcoming summits that we're having. These are conferences that the Cloud Foundry Foundation's managing. I'd be remiss not to mention these. We have one coming up in Berlin on November 2nd and 3rd, and then we have another one that will be in Shanghai, China, in December 2nd and 3rd, interestingly enough, so one month apart. And then early in 2016, we'll come back to North America, and there'll be a good multi-day event that will occur there. So go to cloudfoundry.org. That can be a jumping off point. From there, you can figure out, based on who you are and what your interests are, how to engage with the broader community.
Okay, perfect. Yep, that's cloudfoundry.org. So thanks again, Chip, Chris, and Yui, and to everyone who joined us today. As a reminder, we'll post the presentation and recording to the CSCC website this afternoon, and that website is cloud-council.org. So if you check back in an hour or so, we should have that posted. And great, I hope you'll join us again for another guest webinar down the road. Appreciate your time spent today. And everyone, have a great day. Thank you.
Thanks, everyone.
Bye.